The major problem seen in standard neural network is it always goes from input to output in one direction and it doesn't store any information about the previous event. But when you are working with sequential data, it might be a simple Google translation example, or it might be a speech prediction, or it can be a stock price prediction. For this kind of sequence processing, we need some kind of recurrence. That means we need to store what's happening behind the time or the previous time step. Well, for this kind of complex data analysis, we can use recurrent neural network instead of general neural network. Well, this kind of neural network always has an input vector, and again we are adding one time. This time factor will be vital because we're keeping a track of each time step. Well, if you see this example, x of t is an input vector and we're providing our y of t, that is our output vector, but we are maintaining the hidden state. The hidden state h of t will update over time, and using this recurrence or the kind of loop, we are going to predict the y of t. To understand this, we need to understand this equation first, like how the hidden state is represented over here. Because in general neural network, we are only using the weight matrix or the functions. But here we are using two new terms that might be the old state and the input vector at the current time. So if you see this example, h of t will give rise to function of w. Function of w might be any activation function or any kind of function you want to use for your neural network. H of t will represent your hidden state. F of w will be the function for the weight matrix, and the ht minus 1 will be our input state. X of t will be our input vector at that current time. So the current time, the previous time, and both the time we are combining or multiplying through a function. So this function might be any standard neural network activity. So for this, we need to understand how the state updation is working. So x of t will be our input, which will be one kind of time step at some point, and you are giving one kind of input vector. And the h of t will calculate, and for that we need some kind of function. This function, I have used tanh, you can use sigmoid or you can use ReLU. So these are the function which you customize by yourself, what kind of activity or the function you want to do with this kind of neural network. Well, I thought to start with tanh. So every time we are always going back, we are checking what's happening behind the time and the current time, and then we are comparing both. We're multiplying, we're doing all kind of activities to see what's happening in our hidden state. Well, using this kind of loop, it will always go to itself. And by updating our hidden state, we can always get the output, which is extremely easy to find out what's happening in the next step. Here I want to expand what's exactly happening in a single recurrent neural network. Well, initially I told, right, the recurrent neural network is nothing but it's a loop. That means, for example, here x of t will give y of t. That same thing we can expand as x of 0, x of 1 to x of t, that's time. Similarly, y of 0 to y of t, that will be our output. This tiny box are our hidden state. These hidden states will update over time and it will again give rise to itself. And this L1 to L3, our loss. This loss kind might be larger, depends on what kind of function we want to do. Well, that again depends on what kind of activities we want to see in our neural network. Well, this is again using the same weight matrices at each time step. So basically each time step will be responsible for predicting our actual output at the end.